Okay, welcome to Shareability Uganda e-learning. In today's video, we shall be handling mathematics, and my name is Nelson Samba. We shall handle and continue with our topics under set concepts, and in these concepts we shall be able to learn more about what we call intersection sets. And we talked about this intersection set. This is a category of sets, and we were able to define what an intersection set is. And we said an intersection set, these are sets which have members in common. So today in this video we shall be able to handle more about Venn diagrams and shading the intersection. If you are asked to show an intersection set on a Venn diagram, how do you do it? If you are asked to shade the intersection set, how do you do it? We shall also be able to list members in the intersection set. Also, we shall learn more about the union of sets, an intersection, union and intersection, union of sets and intersection. Okay, so let's get started. We shall be having our set here, and in this set we shall be able to talk about drawing Venn diagrams and shading the intersection. Okay, we have an example here which has been given to us, shading the intersection and in this example we are going to learn about how do we come out with this, and what does this mean. As we've been given from the recent video, we are able to learn on defining an intersection set. We learn about a simple, how do you present if you want to show using simple, so we can still have we can still see this as a symbol of our intersection set. Today we are learning about how do we present them on a Venn diagram. Okay, here we have been given our set. We have been given our set A and our set B, but they are already joined together. An example, we can have our set as this. If we had our set as this, and we call this our set A, okay, call this our set A, and we get another set, and we call this set B. Okay, in so doing, these are different sets. Okay, so in this different set, our set A and our set B, we can be able to show the intersection of these sets. Remember, these sets, they might be having elements, now these elements are of the same. When you get elements who are of the same or who are common in B and in A, we shall say those elements we can be able to present them on as an intersection. Okay, so in drawing Venn diagrams and shading the intersection part, we have been given an example here that from our set A and our set B, they were able to combine these sets. They were able to combine them together, and they came out with this, saying this is A and this is B. Okay, so in writing them they say A intersection B is shaded. An example in combining them, this is very simple, anyone can do it. You can see if that is our set A and this is our set B, say this is our set A and this is our set B. By so combining them in this way, we shall be able to say that this is our shaded, this is our what? This is our shaded region that represent the intersection. Is it right? So here by so shading them, we can shade this. I may not be accurate, but when you shade this one represent our intersection. Okay, this one represent our our intersection part. So we can say that one represent what? Our intersection part. So also in so doing this, we shall be able to look at more and more of how we do that. So when you are asked and say represent the intersection by shading the what? By shading the region, we shall be able to present something of this kind. Okay, this is the same as how they came up with this. Okay, let's continue. We shall also be learning about listing the members in the intersection, listing the members in the what? In the intersection. That means here we are going to look at if you are given members, how do you list them in the intersection, part. Okay, here we have been given an example. We have our set U and we have our set V. So in these sets they have listed the members. Okay, in set V they have also listed the members. But to understand intersection, listing those members which are in the intersection, we have to be very keen and look out which members are in set U, which members are in set U, and which members are in set V. Okay, that have in common or which are the same. Okay, we have to see and look out which members very well. Here you have to see with your very eyes. Okay, so in so doing this, we shall be able to see which members are in what? Are in set V and the same in set U. Okay, can they be able to list them? Can anyone see them here? Okay, we are going to tick those members which are in set U and in set V. So we shall come here and look at this member, a 0. Do we have a 0 in set V? The answer is no, we don't have, so we shall not take it. Do we have a 1? We have a 1 in set U. Is it also in set V? The answer is yes. We tick this 1 which is both in set U. We also come to another number. Do we have a 2 which is we have a 2 in set U? Do we have it in set V? The answer is no. Okay, we have a 3 in set U. Do we have it in set V? The answer is yes. So we tick this. We also tick this because they are in set U and in set V. Come to a 4. Do we have a 4 in set V, in also set V? The answer is no. We shall not tick. Another one, we have 5. Do we have a 5 in set V? Yes. The yes, we tick it. Then also we come and tick it. Then we also come and look at, do we have a 7 in our set U? Do you have a 9 in our set U? It is not there. That means these members who are common, okay, these members we have ticked, they are common in both what? In both sets. They are in both, they are in set U and in set V. That means those members are representing the intersection of a set. They are in both set V and in set U, so they are intersecting members. They are both in this and also in this, okay. They belong to everywhere. When you go in set U and in set V, they are there. So we shall be able to draw our Venn diagram. In drawing our Venn diagram, we shall be able to list those members which are in our set U and our set V. Okay, so like when we talked about this, we said in drawing the Venn diagram, you look for you get your whole set and join them together. So the members which are intersecting, you put them here. That's why here they have been able to bring our members. Before we put them here, you can first list them like the way we did up, and we say which members are in both sets. Can someone mention them? Yes, we have a 1, we have a 3, we have a 5. Okay, we have a what? We have a 5. These members are in our what? Are in both sets. Okay, these members are in what? They are in both sets. So that means in drawing our Venn diagram, this part is the what? Is the intersection of the set. So we shall be able to bring first these members. These members, 1. We shall be able to bring these members in our what? In our the intersection. We shall be able to bring a 1, bring a 3 here, we bring a 5 here, we bring a 5 there. Okay, sorry for that interruption. Okay, yes, we are here. We are saying we shall be able to bring these members here, okay, and see the intersection of set V and this one. So it is the same done here. That's why these members 1, 3, 5 have been allocated this as intersection. And now the remaining, we see we have a 0, we have a 2, we have a 4. These are the ones that have been indicated. Which other members are remaining in our set V? Yes, we have a 7, we have a 9. So these are the members 7 and 9. Now after you have presented this, that means you have allocated everything in a good order. Then you can say therefore U intersection V is equal to 1, 3, 5. That is how they work out with listing the members in the what? In the intersection. Okay, So we are also being given another example here. Another example is set D. Set D. Set D is equal to P Q R S T, and have our set E has been is equal to F Q R P. So they are saying who can find out the intersection of this set. By finding the intersection of this part, we are saying we look for those members which are common in set D and in set E. Can we also take them? Yeah, we have a P. When you come and look for a P here, we also have it here. Okay, we have a Q. Can we get a Q here? No. We have a R. Can we get an R here? Yes. So we tick it. We give it a tick because it happens in all sets. Do we have S? S is in D, but is it in E? No. We have a T. Is a T also in this? No. So here we shall be able to conclude and say our D intersection E, the number the members in which appears common with E are P R. Okay, if you are asked to list how many members are in the intersection, we shall also be able to see them as we learn. Okay, so we also have that here, that number of elements in the intersections. We also have the number of elements in the intersection. If you are asked how many members are in the intersection of this are in common, that's what they are meaning here. So here let's look at how do they find that. Okay, we have this example here. We are saying our set S is equal to G or T of I beg my pardon, our set S is equal to G or A T. Okay, and we have our T is equal to R or T. Then how do we find the number of the intersection of this set? Here we have been given that you first list all those members and you find out. You see which members are common. We have a G. Do you have a G here? No. I have a O. Do you have a O? Yes. We take it. A. Do you have a here? No. We don't take. We have a T. Do you have it here? Yes. We take it. Okay. This one also we take it. We have a T. Yes. We take it. Do you have a O? Yes. We take it. These are the members which are common. So here they want you to know how many are they when they ask for a number. So S intersection, this is this. They are listing them there, or T. Therefore, the number of elements also may mean members. The number of elements or members in the intersection set are 2. How do they come up with 2? By just a mere counting them. When you count, this is 1, this is a 2. So therefore they say number of S intersection T are 2 elements. Okay, can we do that also to this that we did, finding the members? How many members are here? If you have been given this one, remember we said we first list them. Here we had already listed them. We said it is a 1, a 2, a 3, and a 5. Then here they want us to find the number of S. This is going to be U intersection V. Okay, we want us to find who can get for us that. Okay, this is, you do this by just a mere counting them. How many are these one? We say 1 2 3. So we shall say our set U number of members in set U intersection V are equal to, I've said there how many? They are 3. So that's how they can do this intersection set. Okay, let's proceed and come to another. This is another example. We have our set X and we have our set Y. These are the members or elements in set X. We have the L, we have O, we have A, we have F, we have B, we have L, we have U, we have F. Then in representing this, as we have been able to learn how we represent this, we are saying we look out for the members who are common. We have L here and L here. Okay, we have O. Do we have O here? No. We have A. Do you have A here? No. We have F. Do you have F here? The answer is yes. So we also take it. These members are in both what? Are in both sets. So these qualify to be the members in the intersection part. If it was shading, we are going to shade these members, but since it is about listing those members, shall be able to put them here. We say our L, which is this one, and our F. Remember, in listing these ones, we list all of them once. Don't come and put them here again and put them here. Remember, we are trying to look out for the intersection part. So here we shall be able to say that y intersect x intersection y is equal to, you list those members. So when they ask you the number of members that are in common, we say this sign means intersection, but the same as common. So number of members of x which are common with the number of y is equal to 2. Okay, so we shall be able to just count them. We say 1, we say 2, they are over. Say here we say number of x intersection y are equal to 2. Then there we can be able to go ahead. Okay, that was all about listing the what? Listing the members of the intersection part. Okay, come ahead and go. Come ahead and look at to another example. Here we are going to look about a union of sets and the intersection these sets. Then here we are going to define, when they talk about a union of set, what comes to your mind? Union of sets. What comes to your mind? Okay, that is the right answer. I know you know it. So let us look at what they mean. A union of sets is a collection of all the members in a given set. You collect all members in a given what? In a given set. This is also a type of what? A type of a set. Like we looked about the equal sets, empty sets, equivalent sets, intersection sets. So this is also a type of a what? A type of a set. So a union of a set is also represented by this simple U. Okay, this simple U also represent a union of set. We also have to be keen in understanding this. We have seen the other side of the intersection set. They are making the opposite of this. So this is a union of set. Here they are saying listing of members in a union set. Now how do we list the members in a union set? We have been given an example here that if P is equal to R, A, E, or O, then Q is equal to A, B, C, D, E. Okay, we have been given these two sets, set Q and set P. They want us to find or to learn a union of what? A union of set. Now, go back here. When they are saying a union of set is a collection of all members in a given what? In a given set. A collection of all members. That means we shall be able to bring these members and these members together and make a union set. So here they are saying what is P union this. They want the union of these two sets, this one and this one. They may tell you what is the union of this set, or they may ask you find the union of P and Q. Okay, so P union Q is equal to, we look for members, we arrange them very well. And remember, when we are writing these members, we are going to write all of them together, but there are members who are intersecting. Can you look at those members? I'm going to give them a tick. This one is the same as this one. Also, we have also this member. It is also in set Q. Do you have another one? No, they are over. These members are pairing in both what? In both sets. Here, in a union set, we don't write them twice. We write them once. That's why here we are able to. They were able to write A and this one once. They never repeated them. Okay. So here in writing all of them together, we shall be able to write A, E, O, U, then Ba, Sa, then Da. Okay, so they write all of them what? Together. They are saying NB, all common members are written once. Okay, that's what I was from saying here, that you write a member once, even if they are common in both sets. In all sets, you write them once. So here we shall also continue about drawing Venn diagram and shading. Okay, so that is good. Okay, we have another example here. It is all about the union of sets and the intersection of what? Of sets. So here we have been given this example here. We have our G, you have our H, and have our L and S. And then we have our F, we have our H, we have our E, we have another E again, and this. Okay, then they are saying G union H. Okay, so here we are trying to present the union of sets in what? When you are given a Venn diagram and they ask you write what is the union of G and H. How do we get the union from this when you are given a Venn diagram? So from the definition of the union of sets, that they are all members collected what? Collected together. All of these members inside, we shall collect them together and make a union of G and H. So here they are able to bring this, and they are able to bring this, which is I, then S, F, H, E, and E. Okay, these ones are represented 2 times and they are different members. So here it says the number of elements in the intersection set are 7. Yes, there we looked at when we looked at the union of sets, there are also what we call the number of members, like we talked about the intersection, what the intersection sets. So how do you get the number of elements in a union set? How do you get them? After you have listed them, you can be able to count and say this is 1, this is 2, 3, 4, 5, 6, 7. These members are 7. Okay, so that is how they get the number of members in a union set. Okay, so we also have another example. How do we present a union of what? Of set, or how do you shade when you are given two sets and they say shade for us a union of G and H. G union H, shade G union H. Remember, when we learn how to draw these diagrams, we are able to bring them together. We have H and this. When they say shade a union, we shall bring this together. Okay, like it was being given here. If we draw one, we can be able to, let me demonstrate it here. If we have our set G, and we have our set H. I'm drawing them very well, and they are looking nice, but you can also do them more nice, like more than me. Okay, so these are our sets, and when they say find the union of these two sets, what you do, you don't just come and circle all of them. No, you first draw all of them together. Okay, then after drawing all of them together, then you, if this is G and if this is H, I know it is looking very small, but when they say find what is G union H, the best thing to do is to shade all this. Okay, you shade all this, shade all this. That is a union of G. That's why here they are able to show you this, that our G and this one, they shade them, so it is a union of that. Listing the members of the union set, here we have looked about it and can be able to learn. Okay, before we come to this, we shall make a recap. We shall be able to make a recap on what we have learned. What have you understood in this? Okay, what have you understood in this? What have you understood in this? We first talked about this these intersection sets, shading the intersection set. We talked about A union B, how do you shade this, and how do we write it? Okay, say A intersection B is shaded, so this is the way how you do them. Then also we talked about listing the members in an intersection set. Listing the members in an intersection set. We talked about first identifying which are those members that are in both sets. We identified it as this 1, 3, 5, and we said these members are the ones which are in both sets, so they qualify to be in the intersection. And we said we first write this these members in the intersection, then we see which members are remaining, 0, 2, and then 4. These, they are here. Which members are remaining, 7 and 9, and they are represented there. Okay, so we also went ahead and talked about these examples. If you can remember, that we take and say, and we tick those members which are in both sets, and be able to list them. We listed them here, and we are able to know how many. If you are asked how many members are those one, and to know how many members, we said we use n number bracket s intersection t. That means number of members s intersection t. You just count them. You say, after I've listed them, you say 1, 2, 3. Here we said these are the members we listed in our set U and V. We said there are 1, there are 2, there are 3. That's why we are able to come with the 3. Okay. Also went ahead and talked about other examples, listing the sets, listing the members in the intersection set. We also looked about these members, listing members in a union set. We define the union set as a collection of all the members in a given set, with the symbol of how you can present a union set. We looked at this one, and that was so nice. So in this video we shall be able to continue more about the differences in different sets. We also handled this one, and in this we shall also be able to continue more and learn about the differences of sets after these topics, after learning about this. So in this moment I say thank you very much. You can check out on our playlist below for the recent lessons you may have missed, and also subscribe in order to get more upcoming lessons for all subjects. God bless you. This is my number, and our e-learning and our email at elearning@sharebit.net. Thank you very much for watching this video.